Okay, hello and welcome. I'm Jason Gumpert from MSDynamicsWorld.com. Thanks for joining for today's event. This is all about Dynamics AX, Lean Manufacturing, and CPQ, and we're joined today by two experts on the topic, Chuck Stewart and John Shook of Infor. So as we get started, please know that Chuck and John will leave time at the end of the presentation for questions, and you can use the Q&A block that you should see to the right of the main presentation window to ask your questions anytime throughout the event. So without further delay, Chuck, let me hand it off to you.
Hey, terrific. Hey, thanks so much. I'm presenting from Cincinnati, Ohio today, where even though it's 42 and rainy outside, when the Bengals are 8-0, it feels like it's sunny and 75. And I'll move quickly away from any football references at this point. Thanks for joining us. This webinar, we're looking forward to sharing some time from your day. John and I are with the Configure Price Quote group at Infor. We work hard to have a deep understanding of discrete manufacturing and all of its trends so that we can create product roadmaps that can help our customers achieve a competitive advantage. Our particular specialty is with configurable products. That said, we wanted to share some research that we think is broadly relevant to discrete manufacturers. So if you wanted to, we could begin a dialogue with anybody who has interest in this particular topic. Today, we'll briefly show how some manufacturers are having difficulty improving productivity fast enough to keep up with their peers. We'll then provide suggestions for getting started, featuring key integration points between AX and CPQ. And of course, we'll leave some time for questions a little bit later at the end. So let's set the stage. Let's take a look at how manufacturers are performing against their peers. I'll start by telling you about the productivity projects that manufacturers have been successfully implementing. For discrete manufacturers, we can't talk about productivity without jumping right into taking a look at the status of lean manufacturing. The strategies for improving discrete manufacturing productivity have been continually refined over the last 30 years, and they generally fall under the heading of lean manufacturing. This is now an advanced profession all by itself. We're not saying that every manufacturer has implemented all of these frameworks, but nearly all manufacturers of any size have examined the lean manufacturing frameworks that are relevant to their specific products and have applied the principles to their basic operations. And they've been doing this long enough that they've become very good at continually improving their manufacturing processes. The problem is that no one could have predicted just how good we'd all become at this. Because so many manufacturers have good to great processes in place now, those good processes, they're the new norm. In other words, lean manufacturing is the life preserver that helps keep their head above water. Without lean, a manufacturer could kick fast for just a little while, but eventually their productivity would fall behind and their prices and quality would no longer be competitive. We've actually got some data to support this, so let's take a look at that just for a moment. If you happen to manufacture computer equipment, you have the benefit of Moore's Law. That law predicts that computing power will double about every 2 years. This basic tenet has held true for nearly 50 years and is partly responsible for the productivity gains of computer equipment manufacturers shown by the orange line in the graph being displayed. But let's set that aside for a minute and let's focus on the vast majority of us who are manufacturing other discrete products. We don't enjoy Moore's Law, and our productivity improvement has hovered at about 1% per year. This productivity is the sum of all the productivity improvements we make, including lean manufacturing, but also includes the improvements in R&D, in sales, and in all other areas of our companies. This, to me, seems a little bit counterintuitive. It seems like productivity would be a lot higher than this. We've got much more efficient equipment, and we have fewer shop floor workers than ever to produce this result. Let's take a deeper look and see if we can figure out what might be happening. Here's a graph that's showing productivity improvement over time, hovering at about 1% a year. The explanation of why is much clearer when you look at it. The first thing that's not obvious to us is that if manufacturers make any improvements, their productivity slips over time because their costs rise. Next, we receive productivity improvements related to all of the lean manufacturing and other projects we do because we can see less labor required and more efficient processes. But we generally don't take into account the third element, which is the cost of capital. As we tour highly efficient shop floors, we don't see the cost of capital, and it's natural not to even consider it, but it's there. It's into the cost of the automated CNC equipment, the reorganized work centers, and all of the supporting systems required to generate that efficiency. When looking at productivity, we've got to consider that third element because it's part of what determines the overall cost to produce, and so it affects the price we have to command for our products. This third element drives productivity back down to hover around just 1%. So to recap, considering the rising costs over time, the lean manufacturing and other improvement projects we all do, and the cost of capital, our productivity has remained essentially flat. This is, at first glance, perhaps a little bit depressing, considering all the work we put in these projects, but there is a bright spot because we believe we've found several areas that discrete manufacturers have not begun to focus on yet. So let's turn to the strategies to get ahead of the curve and to make productivity improvements that pure manufacturers are overlooking. John and I sifted through dozens of projects that we've seen our customers execute to improve productivity. We generally found there are two kinds of projects where there are highly developed solutions available, but which quite a few manufacturers still haven't implemented. We call these the next wave of lean, and we'll explore these first. The first project focuses on fundamentally changing how bills of materials and routings, or manufacturing instructions, are created for configured products. To be clear, what we mean by configured products is those products with unique specifications or features and options or customizations that actually alter the manufacturing process. Let's take a look at how a lot of manufacturers, perhaps even the majority of them, create bills of materials and routings. First, they go through an effort to pre-set up thousands or even millions of what are usually called star parts. When an order is taken for a customized product, the system will generally search through the catalog of parts to find one with an exact match of all the attributes of the product that has been ordered, and then it will retrieve the corresponding bill of material. There are three problems with this approach. First, the upfront setup of all of these parts is difficult, if not impossible. For example, if the configured product has height, width, and length dimensions that can each vary in just half-inch increments and up to 10 inches in each dimension, it would require 8,000 bills of materials to be set up for that one single product. And that doesn't consider all other attributes that might vary for that product. It doesn't take very long for millions of parts to be required to set up all the bill of materials for that one particular part. The second problem is that searching for that right part to get the proper bill of materials may take a significant amount of time. And in high volume ordering situations, these searches pile up on each other and can delay the initiation of the manufacturing process. The third problem that manufacturers face is that whenever a single attribute is changed, let's say a new color is added, it requires some method of mass maintenance of all of the part bill of materials. In this case, we need to add another 8,000 items just to support one color addition. So in general, it's very hard to create a mass maintenance capability across bill of materials because of the complexity of bill of material structures. So this maintenance often has to be done by hand. The good news is an alternative to this approach exists. We have a strong opinion that this is the better approach, and here's how it works. First, use only one single bill of materials and routing for each product. Create what are called rules to determine how unique bills of materials and routing should be generated on the fly as customized orders are received. The approach of dynamically creating bill of materials and routings when orders are taken rather than in advance has a number of advantages. It's far easier to set up these rules than it is to set up millions of parts with bill of materials, and there are far fewer chances for errors in the rules than there is in the effort to set up all of those parts. Another advantage is that the system can generate the bill of materials and the routings very quickly, so manufacturing is never delayed. And finally, as you make product innovations or you change features or you even improve the manufacturing process as part of your lean initiatives, all that needs to be done is to update the set of the rules that create the bill of materials and the routings at one single point. Our team has implemented dynamic bill of materials and routings at hundreds of manufacturers, so we have a lot of experience helping customers examine their options. If this particular area could be useful to you, we'd be happy to connect with you after the webinar or anybody else and explore that opportunity. We believe it's one of our core competencies. We call this a next wave of lean project because these rule systems exist today and they can be implemented with a high degree of confidence. The second project we'd like to discuss involves shop floor drawing automation. In general, manufacturers of configurable products have an extra step required in their manufacturing process, and that involves the production of shop floor drawings which ensure that employees in the plant know precisely what they are manufacturing. These visual cues really help reduce the manufacturing errors. Actually, let me say that the shop floor drawings reduce manufacturing errors most of the time, but sometimes they can actually introduce errors. Here's how. In general, shop floor drawings are created by a person, typically either a CAD designer or an engineer in the company or any other trained individual. This person takes a look at the specifications on the customer order, pulls up a CAD model of the product that is close to it, and then alters that model to match the specific customized specifications. While all this is done at a CAD workstation, the process is still manual, to read the customer specifications and then to go enter them back into the CAD system. This manual effort is a key point where errors are introduced into the manufacturing process. While the plant may do a perfect job of manufacturing to the instructions that they've been given, the instructions themselves may have flaws. Let's take a look at how even a small error, say a mistyped dimension, can have a really big impact. The manufacturing process we've been talking about fits into a broader quote-to-cash customer process. This process we're looking at here begins with receiving a customer order and wraps up when the product is shipped and is installed at the customer site. But look what happens to these little errors. Because the shop floor produced exactly what they were instructed to, and that they had no way of knowing it wasn't what the customer ordered, the product got shipped, and it wasn't until installation at the customer site that the customer noticed that the product wasn't correct. To fix the problem requires a tremendous amount of time and cost. We got to find the cause of the problem, recreate new shop drawings, which is the second blue bar, expedite the material lead time, remake the product quickly, and then ship it. Not only does this eat into product margins, but it also erodes the customer's confidence in their supplier and reduces the chance of future business. This means there's a big incentive to eliminate these errors in the shop floor drawings. So how do manufacturers typically try to get to 100% drawings? Well, typically, they take the wrong approach. They add a Q&A step to the shop drawing process. It's the wrong approach for a handful of reasons. First, even if a Q&A step is added in, it's very hard to inspect quality into shop drawings. Even if a reviewer can detect the errors on the first drawings they review, the process of switching back and forth between customer specification documents and the drawings becomes so tedious that the reviewer begins to be less effective. Second, it adds time to the manufacturing process. We're all trying to reduce manufacturing time, not to increase it. And third, it is directly counter to the general manufacturing strategy of eliminating errors in the first place, rather than detecting them after the fact. If you're a Six Sigma black belt, this isn't the approach you take. Nevertheless, manufacturers typically try this for a period of time after a serious customer problem, and then abandon it when errors continue to slip through at about the same rate. So let's take a look at a much better approach. It's now possible to automate the shop drawing effort. Rules can be created that automatically combine customer order specifications with CAD models to generate unique drawings for each new order. This completely eliminates the manual effort. If an error creeps in somehow, it can be corrected once in the rules with the confidence that it won't happen again. Instead of increasing the customer lead time by adding an inspection step, this process can reduce customer lead time. And for some manufacturers, this may mean several days. Lastly, it eliminates engineers having to step into the drawing prep process, which frees them up to focus on innovation. So we continue to be surprised by how many manufacturers have not automated this process when the technology is readily available, and it's available now. This is an area that we have several case studies and can easily show you if it's relevant to you. Let's recap. We acknowledge and applaud the tremendous amount of lean manufacturing progress there has been over the last 30 years. Nearly all manufacturers have made lean inroads, and if you haven't, you should consider it now. All of this lean, however, is not enough since your peers are making similar progress. We mentioned 2 strategies for competitive advantage, including automated bill of materials and automated shop drawings. These projects should be considered in the near term to get some quick wins. Now, let's look specifically at the Infor Configure Price Quote solution and what we've done to address the earlier lean discussion for AX and how it helps our customers. The Infor Configure Price Quote application helps discrete manufacturing customers design, market, sell, make, and deliver configurable products. Examples of some of the micro verticals that we work with include industrial equipment, high-tech, specialty vehicles, building products, construction equipment, measurement devices, boats and watercraft, and of course medical devices. Our Configure Price Quote application addresses tough customer challenges like declining sales that are the result of products that are hard to sell, or reps that aren't productive and have long lead times for introducing new products, increasing costs that are driven by order errors, rework, and scrap, and a lot of duplication of efforts. And of course, brand commoditization resulting from being difficult to work with and having cookie-cutter products. We address those tough customer challenges with a complete solution. At the center of the solution is a product configurator, which allows us to make it easy to select and quickly configure your products. The product configurator is surrounded by a set of applications which provide advanced capabilities such as design automation, which enables you to include auto-generated CAD files and drawings as part of your sales and manufacturing process. The sales portal, which extends the power of the product configurator to your sales channels, making them self-sufficient and able to offer a superior customer experience. And document automation, which enables you to assemble and deliver complete, accurate, personalized proposals in minutes. All of these capabilities deliver considerable value to your organization. That value is amplified when it's connected to your Microsoft AX system. The Infor CPQ tool addresses tough customer challenge with a complete solution that provides robust capabilities. I'm going to highlight just 5. Easy configuration of complex products, multi-channel quoting and ordering, dynamic images, drawings, and models, whether they be 2D or 3D, compelling proposals, and anytime, anywhere access. Let's take a closer look at some of those. Easy configuration of complex products. The Infor Configure Price Quote tool makes it easy to select and configure complex products with a powerful and visually appealing experience. This is an example of how a specialty vehicle manufacturer uses a variety of techniques to guide the user to the right product, whether it be through checkboxes, radio buttons, images, or drop-downs. It ensures only valid options can be selected and can even be set up to include additional features or options or accessories to help to upsell the customer. The Infor Configure Price Quote application provides a manufacturer-branded self-service selling portal to empower all of your sales channels, inside sales, outside sales, regional managers, dealers, distributors, manufacturers, reps, all with the ability to configure, price, quote, and order products directly. The tool also has very powerful visualization capabilities to support the selling and the manufacturing experience, whether it's static lookalike images like you see in the bikes, or automated real-time rendered images like you see with the chairs, or dynamic 2D or assembled 3D CAD models as you see with the door and the gearbox. These capabilities can be used to provide visual confirmation of what the user has selected, in addition to being used downstream in the manufacturing process. The Infor Configure Price Quote application also automatically can assemble a variety of documents the user needs to form a complete, accurate proposal. On a case-by-case basis, the user can select whether they want to include things like cover letters, spec sheets, warranty information, terms and conditions, marketing collateral, contracts, etc. Whether you're working at your desk, on the road, or side by side with the customer, the application is accessible anytime, anywhere, and on any device. So, the Infor Configure Price Quote tool enables It enables our customers to design, market, sell, make, and deliver configurable products. It helps them address tough customer challenges like declining sales, increasing costs, and brand commoditization, and it does it with a complete solution that provides robust capabilities. That drives real value for our customers by increasing their sales, reducing their costs, and helping them to differentiate their brand. What does CPQ for AX Lean Manufacturing Support accomplish? It allows the configurable products to use lean functionality. We mentioned earlier dynamic bill of materials and routings. We also talked about the ability to create CAD drawings, 2D or 3D, more or less on the fly, directly from the user input. We'll also review Kanban support. Perhaps a couple of the ways that we help most support the lean manufacturing concepts is by providing accurate information 100% of the time and reducing the manual effort to keep up with the overall business flows inside of our customers. Let's see how. At this point, I'll turn it over to John, who will give an online presentation of the application.
Okay, thanks, Chuck. That was a great background. We'll go ahead and get started once I share out my screen. All right, there we go. So as Chuck mentioned, we'll get started today. Just take a look at a couple of the concepts around lean manufacturing. And we'll get started with looking at something a little bit more aligned with a typical discrete manufacturer, but in the context of dynamically generating an as-configured bill of material and routing, all supported with additionally dynamically generated information to support the manufacturing process, inclusive of a two-dimensional drawing as well. So to do that, we'll just go in here and we'll go ahead and create a new sales order. And that's not really important as it relates to the customer that I'm choosing here at this point. I just need to get a new order established. We'll go ahead and create this order here for Forest. And the product that we're going to start with configuration today is our wood door. And right now I've just added the wood door. This is a configurable product. You can see that the BOMs here are custom. And to go ahead and configure that, we'll just come over here to the product and supply, and we'll hit the configure line. At this point, we're going to initiate into the configuration process. A couple of things just to note, as Chuck had mentioned during his overview presentation, is that the configuration process has many different ways to present a user experience. One that is very visual to allow users to be able to make a very informed decision about the products they're selecting. Those of us who aren't familiar with wood species may not appreciate the differences in the various wood species that are available, but during the configuration process, you can provide additional information to the user to allow them to make a very informed and an intelligent decision, knowing that a particular wood species may be better applicable in certain environments than in others. And so whatever the product option is, however it relates to your industry, you obviously have lots of different sources of information. Making those available during the configuration process is very powerful to enable the users to make the appropriate selections and be able to get the configuration right the first time. As you would expect during any configuration, as I make option selections, we can see that the options below it are filtered out accordingly. A couple things to note, as I chose cherry, you can see that I have a cider option. As I go over here to hickory, I also have a cider option and I have a natural. Now you can see that the colors here and the shades are actually a little bit different as I go from, say, cherry cider to the hickory cider, as well as when we look at the natural for hickory versus, say, the natural for maple, quite a bit different. So again, a very visual configuration experience has a really significant impact on making sure that the user is very well informed as it relates to the options they're selecting. As Chuck had mentioned, lots of different ways to be able to view information. I could certainly select information from a drop-down. We also have a special control that allows us to be able to view images as well as a drop-down. So here, again, I can make a very informed decision if I'm not exactly sure what a scoop panel looks like. I have that image there available for me to select from, or if I knew exactly what I was doing, I could certainly just select from the list of options. The next thing that you see here is on the right-hand side is that we've actually generated now an as-configured drawing. And this is an actual drawing that's been generated in real time. So as I make option selection choices, we're going to see this drawing update. And again, I'm referencing this as a drawing because this is actually generating a CAD drawing real time during the configuration session versus just retrieving a static image. So as I go through and I make a couple additional changes, let's say maybe we'll go ahead and expand that out to a 32-inch wide. Might not be able to really tell, so we'll go ahead and add some dimensions onto that so we have a little bit better visibility to the types of things that we're changing. At this point, I'm going to go ahead and I'm going to finish the configuration process, as I have a few different examples I want to be able to show. We'll come back and look at a door in a little bit more detail later. But as I finish the configuration process, a couple of things to note. As we return back, you can see I've updated my configuration dimensions. I have the configuration of maple, I have a size of 32 by 80, and I have my color of the maple natural. I've also updated the unit price here at $350 based on that specific configuration. A couple of other things that are really important to note, and this gets into some of those lean concepts that Chuck was speaking to, is as a result of configuration, we'll take a look at the composed of tree. So I have some manufacturing rules that are in place that tell me how I'm going to be building my door. This is a fairly simplistic view of my wood door, and we'll see a little bit of a variation of this here in a minute. But I do have some sub-assemblies in here that are consuming some materials that are specific to the type of wood species that I selected during my configuration. Not only that, but then as we look at the bill of material and we'll explode the BOM line, I've been able to add some additional size dimensions to each of those sub-assemblies. So this also provides some additional and relevant information that's specific to the configuration of that door. The other thing to note as we look at the line details down here is similar to the bill of material, we've also dynamically generated a routing. So here as we look at the product details and I look at the details now of the routing, we'll see here that I again have my routing defined. You see I have a couple of dimensions associated with that routing as well. And we can look at, there's just 3 process steps in this particular routing. We have attaching the left side rail, inserting the panels, and attaching the right side rail. To look at one last thing related to the attachment now of drawing, the dynamically generated drawing into the line item, we can take a look that we have that here. We'll show the file. And so this again is showing the as configured drawing. So this is attached into the line item to be able to provide that accurately, dimensionally accurate drawing down into the shop floor, as well as any additional information, a very high level view of some of those configuration options. But again, all this being driven through the configuration process, providing this information back into Dynamics AX to help facilitate a very lean manufacturing process. All right, the next thing that we'll show here is we're actually going to go ahead and reconfigure this line. So once I've configured it and I've generated all this information, it doesn't mean that I'm stuck with it. I can certainly go back and make some adjustments. So in this case, we'll come back in here and maybe we'll switch this over, say, to an oak door, and we'll keep a natural finish on that. And then as I continue through the process just to validate the options I selected, you see I'm not having to rekey anything. It certainly keeps all that information available. Maybe in this case, we'll want to go ahead and make this a really wide door, so we'll make that 40 inches. You'll see now that door spreads out to 40. Here we have a lock rail position, and I'm not sure if I need to measure the lock rail from the top of the door or from the bottom of the door. So again, we can add some information to alert the user that, hey, this is measured from the bottom of the floor, so I know that I'm going to be measuring from the bottom up. So let's just say you want this at 34 inches. And again, this dynamically generated drawing gives me the ability to very visually confirm that this is the exact configuration that I want. Again, it gives the power to the user to help an inexperienced user ramp up very quickly to understand the choices that they're making, or even an experienced user to give them a bit more of an intuitive and also very immersive user experience. The next thing that we'll do for this particular door is we'll go ahead and add some hinges. It adds some additional detail to the drawing, but also adds a little bit more detail to my manufacturing output as well. Certainly all of the user experience here is very much controlled in terms of how you build your configuration model. I may not want to allow a user to make changes to the location of the hinges, but in some cases maybe I do, as I might relate to some special processing or some engineering changes. And so you can see that I've updated that first hinge location to be at 14 inches. So as we finish the configuration, a couple of things again that we're going to note as we return back here. You'll see that my BIMs are updated, and we'll see here I have the oak, and it's a 40 by 80 door, the oak natural finish, and it's now at a price of $308. If we come back here and we take a look at this composed of tree again, we'll notice that we have an additional component as well as some different materials. So here we have the additional component for the hinges, as I had selected the hinges for this particular door. So again, dynamically generating that very accurate information, as well as consuming a different material. In this case, this is the oak material being consumed for each of the component parts within this door. Again, you can see just through that reconfiguration process, we're updating the bill of material accordingly. Of course, if we come back here and we take a look at our exploded BOM view, again, we'll see the similar type of information, adding the hinge, which was in addition to what we had done previously. And then as we take a look at the route here, we'll see just a little bit more detail in here as it relates to how, again, we're going to support these lean manufacturing concepts, providing very accurate, complete information down to the shop floor, specifically as we look at the hinge placement. So we're going to look at the attached hinges, and through the configuration process, not only am I able to define all the attributes related to the routing operations, to the run times, setup times, et cetera, to the resource requirements, all that certainly being driven very dynamically through my rule definition, but I'm also able to specify any additional notes. And you'll see here the hinge location 1 is at 14 inches per that configuration. So for each of the hinges, I've been able to pull back into the routing operation additional description of information that's really going to help support a very specific and accurate and complete manufacturing process. All that cuts down on rework and scrap and really optimizes your manufacturing operations. And then again, of course, as we saw previously, just to show that we have updated line item attachments related to the drawing that's generated, we'll see here that again I have the drawing with the hinge at the 14-inch placement, and I have that 40 by 80-inch door. So that's just a quick example to go through a more of a typically defined discrete manufacturing process, but one that's maybe optimized for more of those lean concepts as Chuck spoke to earlier. The next thing that we'll take a look at, we'll go ahead and add a new line on here. We're going to take a little bit of a closer look at some of the lean manufacturing of the Kanban cards within AX. And so here we have that set up for a product called a fish finder. And again, we'll go in through the configuration process. We'll configure this line item. And as I configure the line item, you'll see that there are some similarities, certainly as it relates to the user experience. I'm asking the user to answer some questions over here on the left-hand side, providing some feedback over here on the right related to the options that they've selected, showing the product image. If I had any types of price details, accessories, et cetera, I could display that information here as well. But without going into much more of a detailed configuration process, we'll go ahead and finish this up because what we wanted to show is the integration now with the AX Lean capabilities and the generation of the Kanban. So here, again, we've created this. We've brought back this one dimension in this case. This is the configuration dimension. The GZ140 is the model that we had configured, or as a result of that configuration. So the next thing we'll take a look at here, we'll go into the production control, and we'll open up the schedule board. And we'll notice here, as I open up the schedule board, is I now have an unplanned card. And we'll go ahead and just switch up here to the current date. We'll go to today's date on my board. And I have this unplanned card. It was generated here, and let's just say we want to go ahead and pop that in over here on Tuesday. So we'll go ahead and add that into the load here on today's date. So the next thing I want to do is we'll go ahead and just show this one more time, and we'll go ahead and take a look at adding another fish finder here, and just to show some of the dynamic ability to generate accurate information is I'm going to do a slightly different configuration that will cause there to be a little bit more of a throughput ratio on this particular configuration. So for this configured line, we'll go through and we'll select still a mounted fish finder unit, but this time it'll be in the color. We'll say do a 10-inch display size. And you can see that, again, I have some different options related to the options I've selected during configuration through a very visual configuration process, and in this case we'll choose the CX911, and maybe we want to add a couple of accessories here as well related to this particular product option. And again, we can see that that price build up or any additional information that we want to display during that configuration process. Go ahead and finish that up. Let's return back, update the line. We see we have the CX911 here for just over $2,000. And if we come back over here and we take a look at our board, we'll just refresh the view. We'll see we'll have now the unplanned card come in. And as I bring that card into say it's a Wednesday, you'll notice that it has quite a bit more resource requirements associated with it, again, based on that specific configuration. So that's what I wanted to just take everybody through today, just quickly go through a few different examples related to how we're able to leverage the power of configuration within Dynamics AX to drive both dynamically generated bills of material and operations, as well as dynamically generated Kanban cards to consume in the more formal AX lean manufacturing process. The last thing I'll just briefly touch on, just to give you a quick view of what sits behind those configuration models, is just a quick appreciation for the fact that this is a configuration model that is very visual. And what I mean by that is it's very easy to work with. It doesn't require somebody to understand how to type in a squiggly bracket versus a square bracket. Is that a forward slash or a backward slash, right? It's not a syntax-based programming language. It's very visual. If I want to add in a new condition in between these two rules, I just click, drag, and I drop. And I use a very simple expression editor here, very similar to Excel, to be able to manage not only what the user experience is, but also to be able to drive down the details of my manufacturing rules related to the materials that I'm consuming, the operations in which they're being consumed, as well as any additional information that is required to support that manufacturing process. So with that, Chuck, I'm going to go ahead and turn it back over to you.
Terrific. Hey, John, thanks. That was a great visual way to tie back together the software with how the Infor CPQ application is supporting the AX lean manufacturing environments. I see we have a handful of questions that have come in over time. If you have a question, please type it into the chat and we'll be able to answer it and respond to it accordingly. Hey, the first question that I have, John, why don't you take? What types of CAD systems do we currently support?
Oh, yeah. So the CAD systems that we're currently supporting would be SolidWorks, Inventor, and Pro-E. So from a 2D drawing generation perspective, if you're just looking to drive 2D automation, two-dimensional drawings, and that would be either SolidWorks or Inventor. If you happen to want to be able to drive 3D models, then we would also provide the ability to use the Pro-E or Creo as well as SolidWorks. And of course, if you're leveraging SolidWorks, certainly there's a lot of capabilities related to additional file types that you can generate as a result of generating a 3D model. So in a lot of SolidWorks, you're also able to generate some DWGs or DXFs as a standard part of that 3D model generation process. And if you have Pro-E, then there would be some additional processing that you could do to drive some 2D drawings from the Pro-E 3D process.
Very good. Ed, a more specific question that just came in as well, John. What is the configuration technology of the wood door that you demonstrated? What was that background?
Sure, yeah, that's the wood door configuration as well as the fish finder configuration utilizes the Infor configure price quote configurator. So that's a configuration solution that supports both product configurations as well as systems of products. So you might not have a simple discrete product. You may have a product that's comprised of multiple configured products or of just a series of non-configurable products as well. And also certainly you might have services related to the installation or setup of those products. So certainly the configurator is able to support both product configuration as well as service configurations. And it's a configurator that's not just embedded into the ERP system, as Chuck, as you had mentioned earlier. It's also able to be embedded into front-end sales tools, such as the Infor CPQ sales portal. We have many customers that have also embedded it into their front-end websites as well. So it's a very robust configuration solution that provides you a lot of value in terms of the leverage that you can have to be able to consume that technology across multiple areas of your organization.
Great. Hey, John, the question is, can we change the production flow process activities that a Kanban go through like you'd be able to for a production route?
Right, yeah, absolutely. And that's the beauty of having a configurator tied to your manufacturing process, is that you're able to apply the business rules to determine which production flow activities you want to consume based upon the configuration attributes or any type of data decision point that you want to make. Again, another powerful aspect of the configurator is that all of the data that you might want to analyze in order to make some decisions around how you operate does not have to reside within the configurator. So it's very easy to leverage standard APIs within the configurator to reach out and touch data that you might manage within other business systems or might manage in other databases. And so you can incorporate all the information that you have at your disposal within your organization, not just within the configurator, to then go ahead and make those intelligent decisions as how you decide to drive your manufacturing operations and production flows.
Good. I have a more specific question about routing and bill of material rules. The question is, what types of data are we typically asking for to develop those rule sets?
Well, I mean, it's certainly going to depend on the type of product that's being manufactured. I mean, certainly you have the typical types of considerations if you were developing a standard bill of material. And what I mean by that, maybe I should say more of a static bill of material. So the same types of considerations as you would have as it relates to defining static bills of material as you might do traditionally, quantity PERs, based on the parent part number, based on option selects. I mean, certainly all those things are going to drive down then into making specific material or item selections. But really, as we look at driving through more of a configurable type of a process, a couple of things that you're going to consider just at the top is what's the structures of your bill of materials related to the various subassemblies, and are there any subassemblies that might be more statically defined? Because you certainly don't have to define every item and every subassembly within your bill of material within the configurator. You can certainly consume standard subassemblies where the items are not configured, where the subassembly may not be configured against a standard subassembly, where the configurator might just really be driving the selection or combinations of those subassemblies. But it may also get into some of the material requirements around the quantity PERs being very dynamic based on, again, your particular product line or different manufacturing scenario where the quantities are going to be dynamically adjusted based on the various attributes of your configuration model. A similar sort of a thing as it relates to your manufacturing or operational run times and setup times. Again, to be able to drive that very dynamically, to be able to have a very accurately costed bill of material for each of the work order transactions becomes very important versus having to, say, generalize that in a static setup. So, there really isn't a limitation at all. It really just depends on how far you want to take it. And my guidance on that would be is to always start a little bit small, understand what the capabilities are, pilot it maybe with a specific product line, and then start to grow from there and expand into other areas of the business from not just even a product configuration standpoint, but even maybe from a demand generation standpoint going outside of ERP.
Great. Good concept. Hey, John, our next question is, does Infor CPQ work as a standalone solution and integrate with any ERP such as Oracle, SAP, M3, BON, or SyteLine? And the answer is yes, it does. However, I would like you to talk specifically about the AX integration that we have.
Yeah, sure. So yes, the answer is yes. It can run standalone, and so that's really a beautiful option as well as it relates to how you decide to deploy. Being the ability to run standalone independent of integration with any ERP system or back-end business application gives you an opportunity to reach your customers very quickly. However, as Chuck, as you had mentioned in your overview deck as well, while there's significant value in running standalone, that value is amplified when you connect it up to your ERP, and specifically the Microsoft Dynamics AX product. We have a tremendous amount of capability there. We didn't get to really go through all the various levels of capabilities that we have. We kind of touched on the high points. But if we also think about extending configuration capabilities outward into your customer base, and maybe let's even draw back a little bit and just say for your sales reps, give them a tool in which they can very quickly and accurately quote your customers and be able to very quickly configure a proposal document. All the work that they do to be able to go through and win that business in terms of a quote through the Infor CPQ sales portal isn't lost. The very great thing is that we have standard integration with Dynamics AX that allows the sales rep or, again, even your customer to be able to just simply click the place order button, and then all that configured information as configured in the quote flows seamlessly into AX to generate the sales order with the as configured sales order lines with the completely defined bill of material routings or Kanbans as you've defined in your configuration model. So lots of great opportunity there to be able to leverage, again, that whole front-end revenue generation with really optimizing and driving further efficiencies into the back-end manufacturing. Very good. And integration is a hot topic on the question board, and I have a more specific question for you, John. Infor CPQ has access to all AX parts and customers. The question is, how is that done? Is it real-time integration, or is it done in a batch mode, or is it a completely separate piece of integration? It'd be real-time, more of a point-to-point type of an integration, leveraging web service calls to be able to access that data. There certainly could be some batch processes, and again, that's going to be dependent upon how we might want to tailor some of the integration to your specific operational environment. But for the majority of the integration, specifically in the context of how we consume the configurator within AX, it's very much a real-time web services-driven type of an integration. And then as we start to extend outward into the front-end selling tools with the sales portal and look at how we manage customer and parts from a front-end quoting perspective, that might end up lending itself a little bit more to a batch process, in that we don't necessarily need to have such a very timely update of information. So that's generally how the integration is facilitated. And that's all standard product integration. So what that means to you as a customer is that you don't have to worry about, how's this integration going to respond to the next cumulative update that is released for AX, or how's it going to respond when there's a new version of the configure price quote. That's all standard product integration. So we have development team and business analysts assigned to be able to streamline that process and deliver that to you, and certainly QA test it, and it's not something that you have to account for in your project plan related to having to make those updates with your own staff.
Great. John, our next question is spot on. Lean initiatives typically have a target return on investment in both time and money. What is the typical target for the implementation of this tool?
Let me see if I can answer it this way. I mean, typically when we engage with the customer and based on our experiences, that we're able to see a 5 to 8 times return on investment. And so that's really what we look at when we're engaged in an opportunity to help understand our ability to help increase sales and our ability to help reduce costs. Those are two areas of our value proposition that we can quantify. It's a little more difficult to quantify the differentiation in your brand, right? How much more revenue can you generate if you're easier to do business with? A lot of times that's very subjective, so we really kind of discount that to the point that we don't address it. But from an increasing sales and reducing costs, we have some factors that we could work with you on. Certainly a lot of organizations have their own ROI tools, but really what we look at is from an overall investment, including software and services and maintenance, is to be able to provide our customers a 5 to 8 time return on their investment. And that's typically seen over a 5-year time horizon. We have a model that kind of ramps that up. We don't assume that you get full benefit year one. Certainly there's implementation involved, and that we'll see typically a positive return starting to occur, after the first year and between the first and second year of implementation of deployment.
Terrific. Next question is very specific to the rules. Would it be possible to disregard the purchase price agreement of key raw materials obtained for bulk purchases for the lesser quantity in the sales order? That's kind of back to our rules definition.
Yeah, I mean, certainly it's possible. Again, we don't come in with a pre-described or predefined format that you have to follow. There's upside and downside to that, certainly. The upside is that you're able to really look at your business and really optimize the business according to how you operate versus how the software operates. And that's typically what we've seen in software over many years past. We really provide a configuration platform that enables you to leverage our tool set to really drive any type of decision, rules, data generation process that it fits your business most appropriately, and also to be able to adjust that very easily over time, because we know that the way that you're operating today isn't going to be the way you're operating a year from now, because if you are, you're probably missing something. Today's business needs to be much more agile. They need to have tools that support a much more agile approach to be able to make adjustments to how they're pricing, to how they're selling, to how they're manufacturing. So that's what our configuration platform provides, is gives you the tool set and the flexibility and also the scalability to really change your technology to support the current operating environments.
Great. John, the next question is, how are the bill of materials that are dynamically created by the CPQ application costed?
So that would be costed through the standard AX process. So we've generated the bill of material, and then so if you do any standard cost rules, then to be able to pick up each of those individual items. Because again, we're going to be picking up standard items. They're going to have the standard item cost based on the amount of material that's being consumed. And then we're also setting the operation runtime, setup times, labor rates, et cetera. And so we're having a fully defined bill of material and an operation that then would allow the rest of the standard AX processing around costing and accounting, of course, to be able to run as it would if it was a statically defined bill of material and routing.
Great. Okay, the next question takes us a little bit out of the centralized discrete capabilities, and it's about ETO capabilities, engineer to order. And the question is, do you have engineer to order capabilities? In other words, can we use your solution to quote equipment that we're not fully standardized and configured?
Yeah, sure. And that's really related, I think, a lot of times in my experience to a workflow process. And we actually have an example where we're able to initiate a workflow within AX. And so, again, very similar to whether we're generating bills of materials or operations for routing or we're generating a price, the configurator is able to generate, right, lots of different kinds of data and also certainly be able to define the rules of setting an attribute. And so when I say defining data, it might just be that we have a certain attribute that we're setting that then we can kind of link into to drive any additional processing within another systems. And so in that context, as we go through a configuration, then we come across something that might be a little bit more engineer to order. It could be a special request, where we have to have engineering review. Whatever the case may be, we can certainly kick out. And when I mean kick out is that we can finish the configuration. We could finish it, say, in an incomplete state that then initiates an AX workflow. And then that AX workflow message would follow the standard AX workflow processing. But then based upon the configurator, able to understand who is using the configurator, right, who launched configuration based on their user profile, they might see that, well, instead of this being customer service that's initiated this workflow request, that I'm now an engineering profile. And as an engineering profile, I may have many other options that are available to me in terms of the product configuration. I may even have options available to me based upon how I write my configuration model and how I want to facilitate my engineer to order process. I may actually allow an engineer to input the item numbers or the quantities or the operations that are going to now support the engineer to order process. And then as a result of making the updates from an engineering perspective and finishing the configuration, then of course it would release now to generate the as-defined engineer to order information and allow then for any additional changes as necessary during the sales order line to be facilitated if the customer is going to continue to make change requests to the order.
Great. Great. I think that takes care of the messages on the Q&A board.
All right. Sounds good. Those are the
Very
big
good.
questions.
Hey, John, thanks so much for your time. I'll turn it back over to Jason for some final comments. Thanks to everyone for participating in the webinar today. Hopefully everyone receives some good value out of it. Enjoy the rest of your day.
All right, great. Thanks, Chuck. Thanks, John, once again for presenting and answering so many questions for the audience. As we close out here, I just want to remind folks we did record today's event, and there will be a survey that should pop up as you depart. It only takes a few seconds to fill out. It really provides great feedback for us, as well as the presenters to know how they did today and what they could do differently in the future. So please do look for that. With that, we will conclude today's event. Have a great day.